In 1991, the Soviet Union collapsed. Western analysts celebrated the victory. Champagne was opened in Washington. Soviet science, they said, was a colossus with feet of clay, a country that could hardly think for itself but only stole other people's ideas and remade them with inevitable losses in quality. It was a convenient explanation. It made it possible not to acknowledge the inconvenient, because in the same 90s, American engineers came to factories in the Moscow region and Samara and fell silent. They looked at Soviet rocket engines and could not find words. These engines operated on a principle that the Americans abandoned back in the 60s. It's too difficult, they decided then, technologically unattainable. And here in front of them stood machines that implemented this principle, serially, reliably, with indicators that American industry could not reproduce either in 10 years or in 20. This is not an isolated story. This is the story of 12 Soviet developments that the West studied, copied, bought, renamed, and at the same time continued to tell the world that Soviet science was a provincial imitation of Western thought. Let's start with the engines. Valentin Glushko lived 80 years and spent most of them trying to figure out how to burn as much energy as possible from kerosene and liquid oxygen. In the late 60s, his design bureau, known as NPO Energomash, developed the RD-170 engine. To this day, it is the most powerful liquid propellant rocket engine ever flown into space. 4 combustion chambers, thrust 860,000 kilograms force. He used the principle of oxygen-enriched afterburning, a scheme in which the generator gas, before being supplied to the main chamber, goes through additional combustion with an excess of oxidizer. Soviet engineering thought solved this problem. American? No. It wasn't a matter of desire. The Americans tried it. In the late 50s, Rocketdyne engineers studied the scheme and declared it practically impossible to implement. Hot oxygen at high pressure corrodes metal, burns seals, and kills turbopumps. They chose a less efficient scheme with fuel afterburning. It was on it that all the Apollo rockets flew, and it remained the American standard for decades. And Glushko continued to work with oxygen. His people developed special heat-resistant alloys and coatings. By the mid-70s, the problem was solved. The RD-170 flew on the Energia launch vehicle in 1987. He lifted the Soviet space shuttle Buran into the sky. Then the Soviet Union collapsed, and the engine was left as a legacy to the NPO Energomash company, without a customer, without government money, without prospects. It was then that the Americans knocked on the gates of the plant in Khimki. A Lockheed Martin engineer named Tom Sackett spent several months in Moscow trying to figure out whether to buy a Soviet engine for American rockets. He expected to see outdated production, Bronze Age equipment, engineers with textbooks from 40 years ago. Instead, he found a full-service metallurgical plant, an in-house forge, test benches with years of data, and an engine design that was unique in the world. Negotiations took a year of daily technical meetings. In 1996, a contract was signed for 101 engines, with a total value of $1 billion. The NPO Energomash company has created a smaller version of the RD-170, the 2-chamber RD-180. It was he who embarked on the first stage of the American Atlas III and Atlas V rockets. From 2000 to 2021, the RD-180 made 122 flights. He launched 16 American reconnaissance satellites into orbit. It carried GPS navigation satellites. He raised military communications equipment and weather balloons. At this time, the American Army officially recognized its dependence on the Russian engine, and the U.S. Congress was looking for ways to finance its replacement. They couldn't replace it. Pratt & Whitney received a license to manufacture the RD-180 on American soil. The U.S. government submitted a request to NPO Energomash for 10 key technologies, without which reproduction of the engine was impossible. Technologies were transferred. The data has been studied. And then they spent $300 million on preliminary work and announced that the engine would not be produced in the USA. The reason was simple. American industry had lost its competence in working with oxygen-enriched systems so long ago that recreating it from scratch required not just money, but a generation of engineers with different experience. As a result, the Atlas V rocket was simply discontinued and replaced by the Vulcan Centaur family with the American Bi-4 engine. Soviet technology turned out to be so complex that it was easier to abandon the carrier than to copy its heart. But the story with RD engines does not end there. It begins. Nikolai Kuznetsov is one of the most underrated engineers of the 20th century. In the 60s, his design bureau in Samara was tasked with creating an engine for the Soviet N-1 lunar rocket. The Americans flew to the moon on a Saturn V rocket with 5 F-1 engines. The Soviet strategy was different. Not one powerful engine, but 30 small ones. This is exactly how many NK-33s were supposed to be in the first stage of the N-1. Kuznetsov created a masterpiece, light, compact, with a specific impulse of 231 seconds in a vacuum, which was an exceptional indicator for a kerosene engine. The N-1 never really took off. 4 attempts, 4 disasters. In 1974, the Soviet lunar program was officially closed. The created NK-33 engines, about 80 in number, were sent to the warehouse of the plant in Samara. Kuznetsov was ordered to destroy them. He didn't follow the order. He secretly kept the engines, believing that one day they would be useful. They lay under the tarpaulin for more than 20 years. In the early 90s, Americans from the Aerojet Company came to Samara. When they fired up one of the NK-33s on a test bench in California, the engine, built in 1970, performed like new. No degradation in performance after 2 decades of storage. Aerojet bought 43 engines, renamed them AJ-26, changed American electronics, added control hydraulic cylinders. On April 21, 2013, the Soviet lunar thruster, created half a century earlier for a race that the USSR lost, lifted the American Antares rocket into the skies over Virginia for the first time. NASA's official press releases said little about this. The word Soviet was rarely used in descriptions of the engine. Usually they wrote Russian or simply engine produced by Aerojet. On October 28, 2014, one of the NK-33s, renamed AJ-26, exploded 6 seconds after takeoff at Cape Wallops. The Antares rocket fell back onto the launch pad. An official investigation revealed a defect in the liquid oxygen turbopump, likely a manufacturing defect from the original engine from the 70s. After this, Orbital Sciences switched to another Soviet engine, the RD-181 from NPO Energomash. One Soviet engine replaced another. This went virtually unnoticed in press releases. Now, about the chair that death needed. In 1969, the Soviet military set a specific task for the Zvezda Design Bureau under the leadership of Guy Severin. The new MiG-25 fighter reached a speed of more than 3,000 kilometers per hour. A pilot ejecting at such a speed would die from the pressure of the air before he could open his parachute. The old chairs didn't work. Something fundamentally new was needed. Severin created the K-36. Unlike Western seats that simply shot the pilot upward, the K-36 did several things at once. Before ejection, special mechanisms pressed the pilot's legs to the seat, his arms to the side armrests, and his head to the headrest. Two stabilizing rods fired forward and upward, creating aerodynamic stabilization in the first seconds of the chair's flight. An inflatable screen protected the face from airstrikes. The system operated at speeds up to 755 knots, according to the instrument, and at altitudes from 0 to 24,000 meters. The 0-0 scheme, that is, ejection at 0 speed from 0 altitude, straight from the parking lot, was implemented without any restrictions. On July 27, 1989, test pilot Anatoly Kovalyov performed a demonstration flight on the MiG-29 at the Bourget air show. The engine failed at low altitude. Kovalyov ejected at an altitude of about 90 meters at a speed of approximately 185 kilometers per hour. The parachute opened at a height of 15 meters from the ground. Kovalyov survived. The entire Western aviation world saw this live. NATO military attachés immediately bombarded their headquarters with inquiries. What kind of chair is this? In 1993, the U.S. Air Force and Navy initiated an official comparative testing program for the K-36, Foreign Comparative Testing. The Soviet seat was tested at Holloman Air Force Base in New Mexico on a special rocket track with a multi-axis system for simulating non-standard positions, and in Russia, on the catapult of the large vertical stand in Zvezda, and in the air, on board the MiG-25 laboratory. The results are still classified, but in a number of indicators, the Soviet chair was superior to the American Martin Baker standard in the range of high speeds and non-standard angles. The American company IBP Aircraft, later renamed UTC Aerospace Systems, opened a plant in the USA to produce the K-36 for American needs. They were talking about supplies for the F-22 Raptor fighter and the Joint Strike Fighter, the future F-35. The plant was built. The equipment was purchased. At the last moment, the American government chose the Martin Baker chair. British, proven, politically familiar. The Soviet chair was technically more convincing. The British one is diplomatically more convenient. Nevertheless, the K-36 flew on Soviet and Russian combat aircraft and continues to fly. In 1993, at an air show in Fairford, a MiG-29 collided with the ground during aerobatics. Both pilots were saved. In 2002, in Ukraine, a Su-27 fell into a crowd of spectators at an air show at Skanilov. Two pilots ejected from an extremely low altitude. Both survived. 77 people on the ground died. The seat couldn't save the people below, but the pilots, who should have died, survived. They talked about what happened underwater in whispers. In 1969, a CIA analyst studied images from a reconnaissance satellite over Leningrad. Sections of the hull of the future submarine were lying at the shipyard. They reflected light differently than steel. The photo interpreter wrote one word in the report: titanium. His colleagues didn't believe it. The U.S. intelligence community has spent 9 years debating whether the Soviets are actually building a titanium-hulled submarine or whether it is just disinformation. The answer came when one of the trucks leaving the plant in Leningrad left metal shavings on the road. CIA agents picked her up. The analysis showed pure titanium. Project 705, designated Alfa-class by NATO, was an automatic submarine. The crew is 25 people, instead of more than 100 on a conventional nuclear-powered ship. The titanium hull made the submarine strong and light at the same time. The working depth of the dive is 400 meters. The limit is, according to various sources, up to 700. American torpedoes of that time could not operate deeper than 350 meters. This meant that Alpha could dive below the kill limit and escape. Submerged speed is 42 knots. No American surface ship could keep up. No Soviet submarine had ever been so fast before. Soviet engineers solved a problem that Westerners considered science fiction. Welding large titanium panels requires an exceptionally clean atmosphere. Any contact with oxygen will destroy the weld. The designers built hermetically sealed workshops with an area of several thousand square meters. Argon was pumped inside. The welders worked in spacesuits with autonomous oxygen breathing. The slightest mistake in a weld meant disaster during deep-sea diving. The pressure difference at a depth of 400 meters is 40 atmospheres. They learned to do it right. From 1971 to 1982, 6 submarines of Project 705 were built. The American fleet received an answer quickly. The new modification of the Mark 48 torpedo could operate at depths sufficient to destroy Alpha. But the technology was studied carefully. Intelligence collected all available data on Soviet welding methods, the composition of the alloys, and the liquid metal coolant reactor on which the boat operated. The cooled lead-bismuth alloy reactor provided energy without refueling for the entire service life of the ship. This was also something that the Western Naval School could not do. When Soviet submarines became available to Western specialists in the early 90s, titanium welding materials were among the first objects of study. Modern American military research programs on high pressures and work with unconventional structural materials bear traces of that work. In official reports, the source, Soviet Technical Standards of the 70s, is mentioned, if at all, in footnotes. Now about the plane that arrived first, but lost to history. December 31st, 1968. Zhukovsky, near Moscow. 18 hours, 37 minutes, Moscow time. The Tu-144 aircraft of the Design Bureau of Alexei Tupolev took off from the runway and flew into the night sky. It was the first supersonic passenger aircraft in history. Concorde took off 2 months and 5 days later, March 2nd, 1969. Tu-144 was the first to break the sound barrier in June '69. Concorde in October. The Tu-144 was the first to exceed the speed of Mach 2 on May 26, 1970. Conquered in November of the same year. The Western press immediately gave the Soviet aircraft the nickname Concorde. Konkordsky, Russian Concorde, implied copy. The reality was different. The Tu-144 was longer, 65 meters versus 62. Faster. Cruising speed is 2,200 kilometers per hour versus 2,180. Accommodated more passenger seats. I flew higher. The cruising ceiling is 18,000 meters. The KGB forces actually worked on the Concorde program. French intelligence subsequently declassified some details of this operation. But the claim that the Tu-144 was a copy is a simplification, convenient for those who wanted to overlook Soviet priority. On June 23, 1973, a Tu-144 crashed at the Bourget air show. 6 crew members were killed. 8 more people are on the ground. The official Soviet version. The crew turned away from the French fighter reconnaissance Mirage, which was filming the plane in flight, and fell into abnormal mode. Western sources have been arguing for another half-century whether it was avionics or people. The disaster closed the Tu-144 topic in the Western press forever. There was no need to criticize him anymore. They simply stopped mentioning him. But the plane flew. In November 1977, Aeroflot opened passenger flights on the Moscow-Alma-Ata route. By this time, Concorde had been operating commercial flights for a year and a half, since January 1906. It was loud inside the Soviet plane, 90 to 95 decibels at cruise. Concorde was quieter in this regard. The Tu-144 engines required afterburner to maintain supersonic speed. Concorde was able to fly at Mach 2 without afterburner. The toilets didn't work. The curtains on the portholes dropped by themselves. The trays were jammed. In May 1978, a new modification of the Tu-144D crashed on a test flight near Moscow. The plane was finally removed from passenger lines. A total of 102 commercial flights were operated, of which only 55 carried passengers. Aeroflot switched to cargo and postal transportation, which continued until 1983. The ending of this story has a bitter taste. In the 90s, the remaining Tu-144s were used to train pilots for the Soviet space shuttle Buran. One of them, Board RA-77114, received funding from NASA in 1995. The American agency used the Soviet supersonic airliner as a flying laboratory for its own research in the field of high-speed aerodynamics. NASA paid, NASA flew the Soviet Tu-144. In official NASA documents from this period, it is called a high-speed commercial transport flying laboratory. Not Soviet, not first in the world, just a laboratory. The world's first supersonic passenger plane ended up working for the American Space Agency and did not receive a single line of recognition for its primacy. When the Soviet spaceship Buran rose above Baikonur on November 15, 1988, he did not yet know that his story would be the story of someone else's achievement. The KGB spent years collecting documents about the American shuttle. According to American intelligence estimates, more than 3,000 documents were stolen, of which 300 related to aerodynamic research in wind tunnels and another 100 related to solid fuel accelerators. This saved the Soviet Union, according to CIA calculations, billions of rubles. There was no need to reconduct bench tests, design the airframe shape from scratch, or develop thermal protection tiles. Soviet engineers at the NPO Molniya Design Bureau received the task to build a device that was outwardly indistinguishable from the American shuttle. The reason was military. The Soviet command feared that an American orbital plane could carry nuclear weapons and fly over Moscow during one orbit. The logic of nuclear parity required a symmetrical response. Buran received thermal protection tiles similar to the American ones, 38,600 pieces made of carbon-carbon ceramics designed for 100 landings. On the underside of the wing, a NASA engineer who studied images of Buran after its only flight, wrote in a secret report, "The Soviets used ablative material in the gaps between the tiles, just like we did before. We have moved away from this decision. They didn't know." But Buran, despite all this, was not a simple copy. It had one fundamental advantage over its American predecessor. The shuttle could not land without a pilot. Buran could. On November 15, 1988, it made 2 orbits around the Earth and landed in Baikonur without a single person on board. Fully automatic landing, 3-point touch. The transverse deviation from the strip axis is about a meter. NASA couldn't do this. When the Space Shuttle Columbia entered the atmosphere with a damaged heat shield in 2003, there were 7 astronauts on board who could not leave the ship and could not change anything. The Soviet ship could land on its own. American? No. The story is ironic in one more way. The APAS docking module, designed for Buran so it could dock with the Soviet Mir orbital station, eventually became part of NASA history. When the American shuttle Atlantis first docked with Mir in 1995, it used a docking port designed specifically for Buran. The Crystal module on Mir carried 2 APAS-89 ports, one for Buran, which never flew to the station, the other for the American shuttles, which flew 11 times. The docking system, designed for a Soviet craft based on stolen American documents, ensured 20 years of cooperation in orbit. Every time the shuttle docked with the International Space Station, it used a derivative of the Soviet standard. This was not mentioned at NASA press conferences. On May 12, 2002, the roof of a storage facility at Baikonur collapsed. 8 workers died. The only flying Buran remained under the rubble. They did not restore it. The program was closed back in '93, shortly after the collapse of the USSR. 70% of the cost of creating Buran, estimated at 40 billion Soviet rubles in 1980s prices, was spent on replicating what NASA was already developing openly as part of a public program. Now, about the maneuver that rewrote the textbooks. The 13th of June, 1989, 14 hours, 46 minutes, Le Bourget. A Su-27 fighter with red stars hovered over the airfield. Test pilot Viktor Pugachev smoothly pulled the handle towards himself. The nose of the plane lifted up, 10 degrees, 30, 60, 90, and continued to move, 110 degrees to the horizon. The plane was flying tail first. In Western aviation, this was called a stall. It was death. A second later, the Su-27 smoothly returned its nose to the horizon and continued its flight as if nothing had happened. 200,000 spectators were silent. Western military attachés immediately sat down to write encrypted reports. The press called this maneuver Pugachev's Cobra. Military aircraft designers around the world began to reconsider their control concepts. The Central Aerohydrodynamic Institute, TSAGI, has been developing the concept of supermaneuverability since the early '80s. The idea was that modern air combat will inevitably turn into close combat, where the winner is the one who points his nose at the enemy faster. The American F-15 and F-16 were excellent aircraft, but they could not fly outside their aerodynamic envelope. Electronic limiters cut off the pilot's access to modes in which the aircraft stopped obeying the controls. The Soviet Su-27 and MiG-29 were created without these limiters. The designers specifically sought to achieve stable behavior of the aircraft at angles of attack at which Western aircraft crashed. The response from NASA and the U.S. Air Force was immediate. According to MiGFlug, an employee specializing in the history of combat aviation, the F-22 Raptor, designed in the late 80s and early 90s, received controlled nozzles, vector thrust, precisely because Soviet aircraft showed that close combat outside the standard aerodynamic wrapper was possible and effective. Not a single document of the American military-industrial complex directly refers to the Pugachev maneuver as the reason for the inclusion of controlled thrust vectoring in the F-22. But the chronology speaks for itself. The Soviet fighter demonstrated the maneuver in 1989. The F-22 received a controlled thrust vector during the design process in the 90s, when data about the Soviet program became available through open sources and direct contacts with Russian designers. The American answer to the Soviet achievement continues to fly as the American fifth generation. Let's go back 30 years, to the Eastern Front. Designer Mikhail Koshkin died in September 1940 from pneumonia contracted during a test run of the T-34 in the snow from Kharkov to Moscow. He did not live to see his tank change the rules of armored warfare. And he changed them in such a way that not a single serious designer after 1941 could afford to design turrets and sides with vertical armor plates. The first German reports of collisions with the T-34 in June to July of 1941 sounded like reports of a meeting with inhuman equipment. Standard 37mm caliber German anti-tank gun shells ricocheted off the T-34's frontal armor at any angle of approach. The 45mm Panzer III guns are the same. Even Panzer IV guns had difficulty penetrating the frontal armor. It was all about the tilt. The T-34 armor plates stood at an angle of 60 degrees to the vertical. With such an inclination, the projectile either went into a ricochet or had to pass through a significantly greater thickness of metal than the nominal 45mm of the frontal plate. The effective thickness of the armor was more than twice as high. A German tank with the same real protection would weigh several tons more. German designers learned their lesson quickly. The Panther, developed in 1942 as a direct response to the T-34, received 70mm of frontal armor at an angle of 55 degrees, sloping exactly like the Soviet model. Tiger II, the same thing. After the war, none of the leading countries in the world produced battle tanks with vertical frontal armor plates. The American M47, the British Centurion, the French AMX-30, they all carried sloped armor. The Soviet principle, born in the Kharkov Design Bureau based on an analysis of the experience of Spain and Khalkhin Gol, has become a world standard. In Western textbooks on armored vehicles, the T-34 is mentioned as one of the reasons for the transition to sloped armor. Koshkin, almost never. A total of 84,070 T-34 tanks were produced. This is more than all the tanks of Nazi Germany combined during the entire war. Now about the little rocket that made a big country. Katyusha appeared in June 1941. An unguided rocket, 8 guide rails, a ZIS-6 truck, a salvo of 16 missiles in a few seconds. The first combat use was on July 14, 1941, near Orsha. The battery commander, Captain Ivan Flerov, fired 4 salvos at Orsha, which was occupied by the Germans. According to the recollections of surviving German soldiers, they thought that an atomic bombing had begun. The land in a square of 300 by 300 meters simply ceased to exist. The Germans immediately began a reverse engineering program. By 1943, they had their own multiple rocket launcher, the Naja-Bellwerfer. It worked on the same principle, saturating the area with rockets instead of aimed fire. After the war, the American Army studied Katyusha and Naja-Bellwerfer. There was only one conclusion. Area rocket artillery is a cheap and effective means of suppression. In the 70s, the U.S. Army began developing the Multiple Launch Rocket System, MLRS. Adopted for service in 1978, the system carries 2 blocks of 6 rockets of 227 millimeters caliber, with a range of up to 45 kilometers. The Soviet BM-21 Grad, model 1963, carried 40 rockets of 122 millimeter caliber, with a range of up to 20 kilometers. Different calibers, one concept: Soviet. The official history of the U.S. military describes the MLRS as a response to the threat of Soviet repeater systems. This is true, but the truth is that the very concept of a multiple launch rocket system as a class of weapon is Soviet. The first serial Grad appeared in 1963, American MLRS in 78. During the same period, similar systems were developed by the French, British, and Israelis, all in response to the Soviet threat, all according to the Soviet conceptual scheme, being both imitators and racers, and none of these countries openly admitted this. Flerov died on October 7, 1941, near Vyazma. His battery was surrounded. He managed to destroy all the launchers so that the secret equipment would not fall into the hands of the enemy. In 1974, he was posthumously awarded the title of Hero of the Soviet Union. The American instructors who trained MLRS crews in the 80s did not know his name. Last page left. In the early 90s, when Soviet archives began to open up, Western aerospace engineers and military personnel gained access to TSAGI, the Central Aerohydrodynamic Institute, which has existed since 1918. What they saw there was unexpected. TSAGI had wind tunnels that were superior to their Western counterparts in a number of parameters. Over decades of closed development, Soviet aerodynamic science has accumulated a theoretical base and experimental data that were either not obtained in the West or were obtained much later. Several American aerospace companies in the 90s entered into contracts with TSAGI to carry out purging of their promising developments. It was cheaper and faster than doing the same thing at home. When the Boeing program ordered one of its hypersonic concepts to be tested in a Soviet tube in the late 90s, it was described as an international scientific collaboration. The word that the American corporation uses Soviet infrastructure because its own does not provide the necessary regimes was not in the press releases. 12 developments. 12 stories about how technology changes the country that created it and ends up in the hands of the country that renamed it. Engines that lifted American satellites 30 years after the collapse of the USSR. The tank that taught the whole world how to install armor at an angle. The supersonic plane that took off first, but in Western history, it remained the Soviet Concorde. The rocket chair, for which they built a plant in Texas and did not buy it. The submarine that proved titanium was the future and forced the CIA to spend 9 years proving something they didn't believe. The history of technology does not like recognition. She loves winners. And the winners write descriptions of the devices without mentioning the original source. This is not malicious intent. It is instinct. When a technology works, it becomes part of the system that uses it and loses connection with the system that created it. Kuznetsov retained the engines against orders. Severin created a chair that saved hundreds of people. Koshkin died of a cold while traveling around the country in a car that should not have existed. Flerov blew up his installations while surrounded so that the secret would not get to the enemy. But the secret still got there, just later and in a different way. They didn't write memoirs about it. They were not given international awards. Their names are not in Western technology encyclopedias. But it is their developments that continue to fly, swim, shoot, and save people, under different flags and with different names.